Thousands of years ago, long before modern machines, ancient builders created structures that still challenge our understanding of what their societies could accomplish. Massive stone temples, engineered cities, enormous water systems, and buildings aligned with remarkable precision. But were these monuments really ahead of their time? Or have we misunderstood what ancient people were actually capable of? From the cliffs of ancient Sri Lanka to the engineering marvels of Rome and the monumental cities of the ancient world, these structures reveal something far more fascinating than a simple mystery. They show just how advanced ancient engineering could become. One of the clearest examples is hidden in the ancient world of South Asia. At Sigiriya, a massive rock rises hundreds of meters above the surrounding landscape. More than 15 centuries ago, builders transformed this natural fortress into a royal complex of gardens, reservoirs, walls, stairways, and water systems. The remarkable part was not simply the scale. Water was carefully controlled and directed across the site, creating pools and fountains within an enormous stone landscape. Sigiriya was not just a palace on a rock. It was a carefully engineered environment, designed to turn one of nature's most dramatic formations into a functioning city of power. But ancient engineering was not limited to palaces and monuments. In the Roman world, engineers mastered something even more practical, moving enormous quantities of water across difficult terrain. Roman aqueducts could carry fresh water for many kilometers, using carefully calculated gradients rather than pumps. Bridges, underground channels, tunnels, and reservoirs worked together as one enormous system. What looks like a simple line of arches was actually only the visible part of a much larger engineering network. Beneath the ground, water could travel through channels hidden from view, supplying cities, baths, fountains, and households. Rome had turned gravity itself into an engineering tool. Yet some ancient cities went even further. At Mohenjo-daro, in the Indus Valley, people were living in a remarkably planned urban environment more than 4,000 years ago. Streets followed organized layouts. Houses were built with standardized bricks, and many homes had access to wells and drainage systems. Wastewater was carried away through carefully constructed channels running beneath the streets. This was not simply a collection of buildings that grew at random. It was a city designed around sanitation, water, movement, and everyday life. And that raises an intriguing question. How did a civilization so ancient develop such an organized urban system? Thousands of kilometers away, another civilization was mastering an entirely different challenge, building enormous monuments from stone. In ancient Egypt, the Great Pyramid at Giza rose higher than any other human-made structure for nearly 4,000 years. Its builders moved millions of massive limestone blocks, created precise foundations, and aligned the monument with extraordinary accuracy. Yet the most impressive achievement may not have been simply lifting the stones. It was coordinating thousands of workers, quarrying, transporting, shaping, and positioning the material on a monumental scale. The pyramid was not the work of a single brilliant invention. It was the result of an enormous, organized engineering system. But precision was not limited to Egypt. At Machu Picchu, centuries later, Inca builders created a mountain settlement where architecture and landscape were carefully integrated. Buildings were constructed from precisely fitted stone, while terraces transformed steep slopes into stable agricultural land. Beneath them, drainage channels helped control the enormous amounts of rainwater that could otherwise threaten the settlement. The Inca did not need modern concrete or steel to build on a mountain. They used stone, gravity, water, and an intimate understanding of the terrain. Machu Picchu was not simply built on the mountainside. It was engineered around it. Some ancient builders mastered an even more difficult material, water itself. In the desert city of Petra, the Nabateans created a sophisticated network of channels, cisterns, dams, and reservoirs that allowed a large population to survive in an extremely dry environment. Rainfall was rare and unpredictable, so every drop mattered. Water was collected from surrounding mountains, redirected through channels, stored in sealed cisterns, and distributed throughout the city. Petra's spectacular rock-cut monuments may be what visitors remember today. But beneath that dramatic landscape was something even more important, a carefully engineered system that made life in the desert possible. Ancient builders also learned how to work with enormous landscapes, rather than simply building on top of them. At Teotihuacan in central Mexico, a vast city emerged centuries before the Aztec Empire. Its monumental pyramids, broad avenues, temples, and carefully organized districts were constructed on a huge scale. The city was not only impressive from a distance. Its builders reshaped the terrain, controlled water, and planned major structures around a carefully organized urban layout. At its peak, Teotihuacan was one of the largest cities in the ancient Americas. Its scale shows that sophisticated urban planning was not limited to the civilizations of Europe, Egypt, or Asia. Some ancient structures were designed not only to impress, but to survive extreme environments. In the Andes, the Inca developed massive stone terraces that transformed steep mountainsides into productive farmland. These terraces reduced erosion, retained fertile soil, and helped regulate water as it moved down the slopes. Carefully built retaining walls supported each level, while drainage layers protected the structures from heavy rainfall. What looks like a simple agricultural landscape was actually a sophisticated system of engineering. The Inca were not fighting the mountains. They were using the mountains themselves. The greatest lesson from these ancient structures is not that their builders possessed some lost technology. It is almost the opposite. They worked with materials, mathematics, observation, organization, and generations of accumulated knowledge. Stone could be shaped with simple tools. Water could be controlled with gravity. Mountains could become farmland. Entire cities could be planned around sanitation and resources. These achievements remind us that technological progress does not always look like modern technology. Sometimes, the most impressive engineering is simply the ability to understand a landscape, solve its problems, and build something that lasts for centuries.